Hello everyone, I am Tahira Mazumder from AKGEC Engineering College. Today I'll be talking on the topic inheritance in C++. This topic comes under the subject Object-Oriented System Designing with subject code KCS 054 under AKTU. So I'll be talking on this topic today. To start with, just let me give a brief idea about the content on which I'll be talking. First, I'll give a brief introduction on what exactly inheritance is. Then I'll talk about the features of inheritance. Then I'll give a brief differentiation between base class and derived class. Then access control and inheritance. On this topic I'll talk, followed by the various types of inheritance that are there. And finally, I'll talk briefly about the constructors and destructors in inheritance. To start with, first I'll talk about the topic inheritance. What exactly is inheritance? Inheritance is basically the process by which a new class which we call it as the derived class. The new class is called as the derived class, and we create this new class from a class which is already existing, and that existing class is also called as base class. So we create a new class which is called as derived class from a class which is already existing. We call it as base class. So that is a very definition of inheritance, the method by which we create a new class from an existing class. The new class is called the derived class, the existing class is called the base class. The derived classes, they have all the features of the base class from which they are inheriting. This is a very important property of inheritance. Derived class have all the features of the base class, and the programmer can finally choose to add new features via the derived class. So derived class carries everything that is there in the base class. In addition to that, it will have some more extra properties or features as per the requirement of the programmer. So basically the idea of inheritance, it implements the is a relationship. It's something like, let us say we know, for example, a mammal is an animal. So we can have something like, we can have a class for animal, we will call it as the base class, and we can derive a class, we can create a class for mammal which will be the derived class, and this derived class will inherit from the base class, and mammal will have all the properties of animal. In addition to that, it has some extra specific features. Similarly, we can have dog is a mammal. So dog, we can have a class which represents dog, which will be inheriting from a class which represents mammal. Hence, we can say inheritance basically models is a relationship. Now, this topic will be more clear as we go to further slides. Now, if we just take it diagrammatically, what is inheritance? So we can say just the example which we just took previously. So we have mammal, and mammals are those set of animals which have certain characteristics, and those characteristics can also be modeled through the programming syntax of classes. So we're not going to the modeling of the characteristics of mammal right now. So we have a class mammal, and we have dog, which is a mammal. What is the characteristics of dog? It will have all of the features of the mammal. In addition to that, it will have some extra unique features. Like, for example, it will have a feature of having strong sensory organ of smelling, which is very specific to dog. So some extra spatial unique features will be there, in addition to the features which it is inheriting from the base class. Similarly, we can say cat is a mammal. It has all the features of whatever the mammal the base class is having. In addition to that, it has some unique features. So here we can say mammal is basically the base class which was already existing, the old class which is already existing, and dog and cat, we will say they are derived class. That means this class are inheriting, dog and cat class are inheriting from mammal class. So to define more in detail, we can say inheritance basically is a mechanism to provide the power of reusability and extendability. How does it do so? Because we have the base class and we have the derived class which it is inheriting from the base class. So whatever is there in the base class is being reused in the derived class, and hence we can say it enhances, or rather it utilizes the power of reusability, and also it adds, derived class adds some extra features. So we can say it also has this power of extendability. So we can say inheritance is basically the process by which one object can acquire the properties of another. Here the one object basically is an object of the derived class, and The properties from another object is basically the object from the base class, right? So it is basically the process by which new classes, which are called as derived classes, are created from existing classes, which you call it as base class. So inheritance basically allows the creation of hierarchical classification. So we'll talk about more about it as we go in subsequent slides. So what are the advantages or features of inheritance? Because whatever is there in the base class gets carried over to the derived class. So we say reusability of code. That's a very strong point which supports inheritance. We don't have to, the derived, when you're coming for the derived class, we don't have to rewrite everything, because if things are inherited from the base class, so automatically whatever is there in the base class will be coming to the derived class by default. We as a programmer don't have to do extra. So it saves time and effort. And on the process, it leads to faster development, easier maintenance, and easy to extend. And it is also capable to express the inheritance relationship and its transitive nature in much more easier way, thereby ensuring correct closeness to the real world property. This is the best example. There's a very strong point in the sense that inheritance very much relates to the inheritance that exists in real life scenario. So we can easily relate to it, and that helps in easier expression of the coding language of the codes. These are some examples of inheritance which are shown diagrammatically. So in this case, class, if you say we have a class which represents point, class named point, for example, and we have a class named line. So whatever is there in the point class, so we are basically saying that the line class is basically a child class or a derived class which is inheriting from the parent class or the base class. So what does it mean? All the features of the point will be automatically inherited by those of the line, in addition to the property that the points, basically line, what is a line? A line is basically a set of points. A line is a huge collection of points aligned in the same dimension, aligned in the same line. So we can say line basically is inheriting from points, because line basically is a collection of points. In addition to that, it has the extra property. The property is that the points should not be scattered. The points should be in unison. It should be placed in such a way that we end up creating a line. So this is about one example. So we have another example. Let us say we have a class called fruit, which has some features signifying fruits, the properties of the fruit. So we have new classes orange, mango, and banana. We call them as derived class or child class, and they inherit from the base class fruit. How does it happen? We'll take it syntactically. The syntax of the grammar, we'll take it in the later slides. This is another example. We have a polygon. We know what is a polygon is. It is a figure which has got multiple sides. So we have a triangle as a polygon where the number of sides is 3. We have rectangle as a polygon where the number of sides is 4. So this base classes, this subclasses or this child class or derived class basically inherit from the base class. Base classes are also called as superclasses. Child classes are also called as subclasses. So we have names like base class, superclass. We have names like child class, parent class, subclass for the derived class. So this one we already explained. Now let us just define these two terms, base class and derived class. So base class is basically a class which defines the qualities that are common to all objects which will be derived from that particular class. So it refers to the set, it refers to a class which has common properties, and on this basis new classes will be created. So basically the base class gives a general description of the properties of that class, more generic in nature. So a class that is inherited is referred to the base class. So base class is a class which is being inherited. So these are different ways of looking at the base class. Now how do we look at the derived class? The derived class is the class which inherits. They are usually the class which is derived from the base class, or rather which inherits from the base class, are referred as the derived class. So derived class basically includes all the features of the base class from which it is inheriting, and in addition to that it has qualities that is specific to that particular class. This point will be more clear as we take more examples in the subsequent slides. And the class that does the inheriting is called derived class. So we can say base class is the class which is inherited, and derived class is the class that does the inheritance. So these are the two ways of looking into base class and derived class. So let us note some important points. Derived class can also be used as base class for another derived class. So we have a class A, which is base class, based on which we have a class B that is derived, and this class B can again be inherited by a class C that is derived. So we have the scenario where B is a derived class for base class A. So it is basically a derived class for base class A, but for base class C, B is the base class. So for class C, so we can say B is a derived class for class A, C is a derived class for class B. So in that case, B is the base class and here A is the base class. So derived class can be a base class also for another derived class. And in this case, in case of C++, inheritance is basically achieved by allowing one class to incorporate another class into its declaration, and we'll talk about it again in the subsequent slides. So now let us come to the syntax part, the grammar part, how exactly inheritance is being taken care of. So to look at the syntax is, we have this, you have to write the keyword class. How do we declare class and how do we define the class? We have to write the keyword class followed by the name of the derived class, followed by colon operator, and after colon operator we'll specify the access specifier. The access specifier, if you know, we already discussed in some classes, it can be public or private, or it can be protected, right? So you need to specify the access specifier followed by the base class, and then we have the body of the derived class within the braces. This is the generic syntax of defining the derived class. For example, if you look at it, we have a derived class named C rectangle, which is deriving from base class C polygon, and the access specifier is public. That means the inheritance here is public. Similarly, we have C triangle, which is a derived class deriving from the base class C polygon, and the access specifier is public. And inside this, we have the body of this particular derived class. What does this derived class do? What are its member functions? What are its member variables? We'll be declaring within these braces. Similarly for C triangle. So this is just a broad syntax for how to ensure inheritance. Now let us talk about access control and inheritance. What role does it play when it comes to inheritance? So when it comes to access control, we have this via access control. If you look at inheritance, we have these three scenarios. One is public based inheritance, which we call it as public base class inheritance. The other one is private inheritance, where we are calling it as private base class inheritance, and then we have protected base class inheritance. So these are the three scenarios that might come or that might happen. So public base class inheritance, in this case, all public members of the base class, all public members of the base class become the public members of the derived class. All protected members of the base class, they will become the protected members of the derived class in case of public base inheritance. I'll take it up more in one more slide. Now, in case of private based class inheritance, public and protected members, they become the private members of the derived class. Public and protected members of the base class, they become the private members of the derived class. But the private members of the base class remain private to base class. So the private member can never be accessed by the derived class. That applies to even public case inheritance. The public member of the base class becomes the public member of the derived class. Protected member becomes the protected member of the derived class. But when it comes to the private member, they can never be accessed by the derived class. Similarly for the next scenario. Now let us come to talk about the third scenario, that is protected base class inheritance. Here, all the public and the protected members of the base class, they become protected members of the derived class, and all public members of the base class, they become unavailable, or rather we can say they are not available to the main function. But the point to be noted is that all private members of the base class, they become unavailable to the derived class. That means whatever may be the cases of inheritance, whether you are going for protected based or public based or private based, the private members of the base class, they will never be inherited, or they can never be accessed by the members of the derived class. So this is the syntax which I already described. So you have the class keyword followed by the name of the derived class followed by colon operator, giving the access specifier and then the name of the base class, and here we'll be writing the body of the derived class, and the access specifier can be either public or protected or private. So I'll talk about more on this. So for example, we have this derived class. We have I'm describing it a little bit more in detail. I'm taking an example. Let us say we have a base class animal. The base class animal. If you just see after this, we don't have anything after colon. We don't have anything written. So that means this is a base class. There is no inheritance. So this is a class, and the body of the class animal will be written somewhere. We are just presuming that the body exists. We are not going into the detail of the body of the class animal. Now we are taking a class amphibian. What is this class? So after this, you have this colon followed by the name of another class. That means it is talking about inheritance. And what kind of inheritance we have? The inheritance is public. That means in this, what does this definition mean? That means we have a derived amphibian is a derived class that is accessing from the base class animal, and the kind of access, which kind of access it is? It is public access. So I'll talk on more on this now. So next is, for example, we have a scenario where you have we have multiple cases. For example, if you look at this, we have a derived class, and this class can be made to access from 2 or more base class. That scenario is also possible. I'll take an example later on in the coming slides. So in this example, you have the derived class that is inheriting from multiple base classes, and so the syntax is you give the derived name followed by colon, and then you give both the base class names prefixed by the access specifier. An example, let us say you have orange, which is a derived class. This orange is basically a derived class, and it is accessing, it is deriving, or rather it is inheriting from class yellow, and we need to specify the access specifier. Let us say the access specifier is public inheritance. From class red, the access specifier we need to specify, let us say the access specifier is protected, and then we give the body of the orange class. This is how the syntax follows. So if you look at this multiple base class scenario, we have an orange class which is inheriting from 2 base classes, yellow and red. Yellow and red are the 2 base classes. So this scenario is also possible where you have one derived class inheriting from multiple base classes. There are different kinds of inheritance. We'll take it up later on. We have another kind of inheritance where we have mango inheriting from fruit. Let us say this is a derived class inheriting from fruit base class, and we have again these 2 are derived class inheriting from class mango. So this scenario is also possible. We call it as multi-level inheritance. I'll talk more on this using the code in the next slide. Now, before we move further about the types, well, let us talk about the summarization of the access control, which we just talked about. The access control way of inheritance, that is public inheritance, private inheritance, and protected inheritance. So before I go into the types more in detail, I just want to summarize one important point. What in the case of base class, every class we know it can have private members or protected members or public members. So every base class, whatever may be the kind of inheritance, the private member of a base class can never be inherited by the derived classes. The derived class can access the protected member and the public member only of the base class. This is a point that we need to remember. Whatever may be the kind of inheritance, the private member can never be accessed. The private member of the base class can never be. The types or the visibility modes related to private, protected, and public inheritance in more detail, or rather more in graphical point of view, so that it will be easier to grasp. So we are talking about the kinds of inheritance. What will happen if the inheritance is private, if protected, or if public? So if private inheritance, so what happens? The private members, the protected members, and the public members of the base class, what happens if the inheritance is private? If the inheritance is private, the private members is never inherited by the derived class. The protected member, and the public member of the base class, all of them become private when the inheritance is private. Now, when the inheritance is protected, what happens? Again, the same thing, the private members of the base class is never inherited. So we can also summarize it like this. If the inheritance is private, public, or private, the private members of the base class is never inherited. It is never inherited. This is a point that we need to remember. And if the inheritance is protected, what the focus is, what happens to the protected and public members. If the inheritance is protected, the protected members, they become the protected members. The public members become the public protected. Both of them become the protected members if the inheritance is protected. Both of them, by meaning both of them, we are meaning the protected members and the public members of the base class become the protected members of the child class. And if the inheritance is public, the protected members of the base class become protected and the public member of the base class become public. This is a point we need to remember as we do the coding. And the private members of the base class is never inherited, be it private inheritance or protected inheritance or public inheritance. So this is more in detail. So private inheritance, if you see like this, the private inheritance, they are never inherited in case of private inheritance, and the public members and the protected members, they become the private members. If the inheritance is protected, again the same thing, the private inheritance and the private members are never inherited, and the public members becomes the protected members, all of them become protected if the inheritance is protected type. And if the inheritance is public type, the public member of the base class become the public member of the derived class, the protected member becomes the protected member of the base class, become the protected member of the derived class, and the private members of the base class is never inherited. So this is a graphical description of what we just studied, and I think this is a better way of remembering the points. So if you take it from coding perspective, so we can say in case of private inheritance, so let us say we have a base class has private members. Let me change the color of the ink. Yeah. So base class has private members and protected members and public members. This is a base class. This is a child class which is inheriting from base class through private inheritance. And in addition to whatever is there, the child class will inherit, and in addition to that, these are the extra features of the child class. These are its private members, these are its protected members, and these are its public members. Like in private, we have integer x as a member and func x as a member function. So in protected, we have y as a variable, as a member variable, and func y as a member function, and so on. Now, after this inheritance, what exactly happens? This is what actually happens. So in child class, whatever is there, it will be there. In addition to that, all the classes from the base class will be coming. Now, from the base class, the private part will not be inherited. Since the inheritance is private, so what will happen? The protected part and the public part, that is int b void func b, int c void func c, will become, if you see, will become the private members. So if you just see in all of this, they are becoming the, if you just see, they all are becoming the, they are becoming the private members of the base class, and remaining it is having as it was. So that is what we are saying. If the inheritance is private, the protected members and the public members, all of them come here as the private member of the base class, of the derived class. If the inheritance is protected, it's the same scenario, the same class. In this case, if the inheritance is protected, we know that whatever is there in the private section, they will never be inherited. So that will it will not come in the base class. The same scenario, we have the child class that is inheriting from the base class, and these are the extra features which are there in the child class. This is the features of the base class. So if the inheritance is protected, what happens? We all know that if the inheritance is protected, the protected members of the base class and the public members of the base class, all of them become, they come under the type protected if the inheritance is protected. Now, if the inheritance is public, same scenario, if the inheritance is public, what happens? The protected members of the base class, in addition to this will still be there in the derived class. In addition to that, the protected members of the base class will become the protected members of the derived class. The public members of the base class will become the public members of the derived class, in addition to the members which is already there in the child class. So this is what happens when you're going for public inheritance. So summarization, this is the body of the base class, this is the body of the child class. Whatever the features the child class have, all of these are still existing in the class. And what actually happens, this is a brief extrapolation of what actually happens. The members of the base class becomes members of the child class, and in what order, in which way they will take the membership, that depends on the kind of inheritance we are doing, whether we are doing public inheritance or private inheritance or protected inheritance. Now, talking further on that, we have 5 kinds of inheritance. Single, we're now the next topic which we're talking about is the types of inheritance. Under this, we have single inheritance, multiple hierarchical and hybrid inheritance. So, single inheritance is the one where we are having a single base class followed by a single derived class. So, this is a single level inheritance. Here, if you look at this single level inheritance, we have a student class, base class, we have a course as a derived class which is inheriting from student, and the inheritance is public. So, whatever basically what these are the extra features or extra characteristics of the base class, of the derived class, and these are the inheritance, these are the members of the base class which will automatically come to student class. And if you just see what is the inheritance is public. That means what? The protected members of the base class will come under here, it will come under the protected members of the derived class. All of these things will be inherited here, and the public members of the base class will also be added in the public section of the derived class. This is what happens. Now, if you are coming about multi-level, next type of inheritance is multi-level inheritance. In case of multiple level inheritance, multi-level, a class inherits from a class that is again inherited from another class. Like we can say you have class A, you have class B which inherits from class A, and class B is again inherited by class C. That means class B is a derived class with respect to class A, and class B is a base class with respect to class C. This kind of inheritance we call it as multi-level inheritance. This is through programming. This is a base class furniture, and we are inheriting a class sofa from furniture. So, class sofa is inherited from furniture, and we are inheriting a class office from sofa. So, office is inherited from furniture. So, and the inheritance here is public and private. So, I already described about the public and private inheritance. I am not describing more here. So, whatever members of the class furniture, they will be inherited in sofa publicly, and whatever is there in the sofa class, they will be inherited in office privately. How it is inherited privately and publicly, I already explained. So, that scenario will be followed. This is a case of, the other one was multi-level. This was multi-level. That means you have multiple levels of inheritance. In case of multiple inheritance, you have a derived class that inherits from multiple classes, and it has properties of both the base classes. So, you have a derived class which is inheriting from class A and class C. So, this is called as multiple inheritance, where the derived class inherits not only from one class but from more than one class. This is how the coding looks like. We have a class chairman, and this is the body of the class where it has got members as chair ID, chair name, protected members. These are the description, and you have got an allocate function. And in the public section, you have chairperson, assign, and show functions. For example, this is for a base class chairperson. So, it's case of multiple inheritance, right? So, we have a chairperson class here. We have director class here, which is the body of this, the body of the director class. And we have company class, which is inheriting from chairperson and from director. So, inheriting company class is inheriting from chairperson and director. And the inheritance for chairperson is private inheritance, and the inheritance for director is public inheritance. So, thereby, and this is its own body, the own body of the company class. So, the summarization is that this is the own body of the director class, the body of the chairman class, and this is the body of the company class. So, in the implementation point of view, company class will have this plus the members of director class plus the members of the chairman class. On the basis of the kind of inheritance, the inheritance is private and public, right? Private for chairperson, public for director. In case of hierarchical inheritance, we can look at it as an inverted tree. Here, multiple inheritance, they inherit from a single base class. So, it's something like this, if you see. So, you have the reverse. Here, if you just see, this is the reverse of this. It's just the inverse of this. You have a single base class and multiple derived classes inheriting from a single base class. So, if you look at it, we have a class toy. We have soft toys, which is inheriting from toy. We have electronics toy, which is again inheriting from toys. Here the inheritance is public, and here the inheritance is public. Both the inheritance is public. So, in this case of inheritance, we call it as hierarchical inheritance. So, it is implicit that this is the body of the child of the class of the base class toys. This is the body of the soft toys class. In addition to that, the members of the toys class will also become member of the soft toys. How the membership will happen? That is on the basis of the inheritance type. Here it is public, so inheritance will be done publicly, following the rules which we just discussed in the previous slides. Here the same thing. These are the individual members of the electronic base or electronic derived class. In addition to that, it will also have the members of the toys class. We are inheriting them publicly, and the rules related to public inheritance will be followed. This is a hybrid inheritance where we have combination of all kinds of inheritance. So we can have, like for example, we have class A which is inherited by B and C, and class D which is inherited, class D which is inheriting from B and C. If you see here, we have a mixture. We have this multiple and level we have inheritance here. Now, let us just talk a little bit more on the role of constructors and destructors when you are talking about inheritance. So here, when you have base class and derived classes, they can have their own constructors and destructors, just like base class. And the point to be noted is that when we have an object of a derived class that is created, now what will happen? You have a base class, a derived class which is inheriting from the base class, and you have an object of a derived class which is created, and we have a constructor function in the derived class as well as the base class. In that case, what will happen? The base class constructors will be first executed. This is the point that we need to remember. Only after the base class constructors is created, then only the derived class constructor will be executed. And when an object of a derived class goes out of scope, that means when the destructor function of a derived class is executed, the derived class destructor will first be executed, followed by the destructor of the base class. So it's just vice versa. In case of constructor, the base class constructor is first executed, followed by the base class constructor. And in case of destructor, it's just the reverse. The destructor of the destructor of the derived class is first executed, followed by the destructor of the base class. These are some important points that we need to remember when you are talking about this particular topic of inheritance. Here, some point related to the size of the object of the child class. So while we are calculating the size of the object of the child class, we need to add the size of all data members of the base class from which it is inheriting, including the private members of the base class and the child class. This is a point that is taken care of when we are going for taking the size of a object which is of the derived class. And if the child class is inheriting from multiple base classes, then how do you find the size of an object of that particular derived class or the child class? In this case, we add the size of the data members of all base classes of the derived class as well as the derived class. That is a point that we need to remember. And in the case of multi-level inheritance, the size of all base classes are inherited by the child class, and it is added to the size of the child class data members. Like for example, we have A which is inherited by B, which is inherited by C. So if you want to find the size of all of an object of class B, so it will add up the size of all members from which it is inheriting as well as the size of all members of that particular derived class. The total value will be the size of the object of a derived class, let us say C. That is in the case of multiple inheritance. So that much for now for this topic. This is some reference books that I have referred to for this particular topic, and that much for now. For now, I'm winding up.